So we have a quite typical exercise from A levels. This particular exercise is from, it's a past paper from 2017, actually the version 1 of the paper, and it mainly has to do with derivatives. So let's start reading the question. It says that a curve with dy over dx is 7 minus x squared minus 6x passes through the point 3 minus 10. And we have three equations here. We need to find the equation of the curve, and then we need to express that, that quantity that we're given in a certain form, and then we have to solve an inequation. Okay, this is a quite easy exercise. It does not need so much inspiration, so the steps are the steps are quite simple. Okay, so I prefer to think of the curve not like that. I don't like thinking that my curve is y equal to something. I prefer to think that I have a function f of x. So what I'm actually looking for is the equation of the curve. So I'm actually looking for the formula of the function. So let's say that I have a function f of x such that, okay, that means that f prime of x is equal to 7 minus x squared minus 6 times x. That's what I know, the first information that I have. And I also know that my function, the curve of the function, let's say, passes through the point 3 minus 10. All right. So here is what we will need what we call the antiderivative. I'm looking for a function that its derivative is equal to that. Okay, so let's start writing it. What do I derive to get 7? Well, that's quite easy. I derive 7 times x minus. What do I derive to get x squared? There is a formula also for that. I derive x squared, x at the power of 3 over 3 in general. If I have x at some power a, in order to get its antiderivative, in order to get what I did derive to get that quantity here, I get x at the power of a plus 1 over a plus 1. Magnificent. And now I have minus 6 times x. So let me just write minus 6. And the question is, what do I derive to get x? Well, that's quite easy as well. I have to derive x squared over 2. Take a look at it and notice that x squared over 2 prime is going to be equal to 2 times x squared over 2. And here we'll have minus 1. That will be equal to 2 times x at the power of 1 over 2. These two go away and I end up having x. So actually, yes, if I derive that, I will get this x, and I must never forget that here I can have any constant. It could be plus 10, plus a million, plus the square root of 10 billion. We do not care about it yet, but it is quite important not to forget it, not to forget the constant. Okay. So here is my antiderivative, and this c here does not know what to do, but there is some sort of information that will tell c what to do. I will determine c from this. I know that f of 3 has to be equal to minus 10. How do I know that? Since my curve passes through the point 3 minus 10, it's going to be somewhere, I don't know, somewhere here, let's say. Since I know that my curve passes through that point, I know that if I drop 3 in the function f, I will get minus 10. So f of 3 is minus 10, and this process, guys, is very, very typical. Very typical. Okay, now so I have to combine now all the things that I know. Let's combine them here. I will have that, okay, f of 3. That means 7 times 3 minus 3 at the power of 3 over 3 minus 6 times 3 at the power of 2 plus c. This whole thing has to be equal to minus 10. Minus 10. So now all I have to do is to solve this equation, do these calculations here, and determine c. Okay, let's do it. Let's actually steal this here. And solve the equation. So let's simplify a little bit the numbers. I have 7 times 3, that's 21, and here this actually is equal to 3 at the power of 2, okay, minus 6 times 9 over 2 plus c. All of that has to be equal to minus 10, of course. And let's see this to get simplified, and I end up having 3 here. So I have 21 minus 9 minus 3 times 9 plus c. All this equals minus 10, of course. So I have 21, and I have minus 9 minus 3 times 9, that's 4 times 9. 21 here minus 4 times 9 plus c. So I have something like that. 21 minus 36 plus c. So c, all this go to this side. Of course, c is equal to minus 10 minus 21 plus 36. That is minus 31 plus 36, and that, of course, is equal to 5. So c here is equal to 5. C here is equal to 5. So I got it. We got the equation of the curve. That's the equation of the curve. Here, instead of writing c, I'm going to write 5. And that here is the answer for the first question. Let's move to the other two questions. It says express that the derivative, in fact, the derivative in this form. Okay, we're going to do this expression because it will be quite helpful with the inequation afterwards. Okay, let's see. We're at the second question. I have 7 minus x squared minus 6x. Now I really want to create a square, a perfect square, so I'm going to leave 7 here by itself. I'm going to take minus 1 as a common factor here. So inside the bracket, I will end up having x squared plus 6 times x. Okay, I haven't done any big changes here. I really want to create a perfect square here. So I'm looking at it, and I see that I have here x squared, and this will be expressed as 2 times x times 3. So what do I need inside the bracket? I need plus 3 squared plus 9, and in this way I'm going to have a perfect square, because now this 6 is going to be, I'm going to write it as 2 times 3, and this is going to be a perfect square. It's going to be something that looks like that. Okay, this is the famous identity. So now have actually destroyed the quantity because I just added something that I wanted. Well, if I want to add something in a quantity, if I want to make something appear, I can just add it and subtract it at the same time. So if we're very careful, we will see that in fact what I added here is minus 9 because, okay, this is the 9 that I want inside the bracket, but it will get multiplied by this minus 1 that it's hidden outside of the bracket. So in order to maintain the equality, I have to add also its opposite. I have to add 9 as well. And I keep on writing. Again, I'm saying I have added minus 9, and I'm also going to add 9. So I have actually added 0 and nothing has changed. So I have 7 plus 9, which is equal to 16, minus x plus 3 at the power of 2. Factorization using this identity. All right, so that was quite easy. A is 16 and B is 3 here. All right, and I will go now to the last question. It says find the set of values of x for which the gradient of the curve is positive. Now, the gradient is this. I have a curve, this is my curve, and the gradient is that, you see? So I actually have here this in equation, 7 minus x squared minus 6x, positive, okay, positive. Okay, there are ways to solve quadratic inequations like that. There is a formula, but we're going to use what we got here in 2. We expressed this quantity in this form, 16 minus x plus 3 and all of that at the power of 2. Okay. And what does this mean? That means that 16 is greater than x plus 3 at the power of 2. And I would prefer to write it like that, to be honest. And now if I take the square roots of both of the sides, be careful, if I have the square root of a and there is a square inside the root, that's equal to the absolute value of a and not a. If I have something like that, this is equal to a. But this, if the square is inside the root, I end up having the absolute value of a. Okay, so I move on here. I have that the absolute value of x plus 3 is less than the square root of 16, which is equal to 4. And now I'm going to use a famous property of the absolute values, which says that if you have the absolute value of x less than something positive, that p here, I chose p because I want this number to be positive, well, x has to be between minus p and p. In fact, this means that x, it becomes a small sandwich between minus p and p. So this gives me that x plus 3 is between minus 4 and 4. And now all I have to do in order to leave x alone and solve the inequation is to add 3 at all of the 3 sides. So we'll end up having minus 4. Actually, sorry, I have to add minus 3, right? I'm going to add minus 3 at all of the 3 sides. So I'm going to have something like that. You see, these two will go away. So the final answer here is minus 7 less than x less than 1. And that is the answer for the third question. Again, I repeat, it's a quite typical question. All these questions were appear a lot in the past papers of paper 1. Thanks for watching. For any questions or anything else, you can always contact me at my email here, korfiati.an@gmail.com.